Welcome to Bhavo's channel. In this video, we'll talk about LangChain, how you can implement easy way in the few minutes a complete LangChain application with powered by any small agent that can be deployed at any cloud platform. Yeah, you deploy it on your local with Olama, yeah, whatever. So how you can build a small agent to big agent, yeah, small use cases to big use cases. Okay, so in the previous video I will talk about that what is LangChain, actually what is a agent. Now I will go how you can implement a basic applications. If you understand this one applications, your one small agent, you can create a big application also with your agentic workflow. So I will talk a STEAM agent. STEAM means student want to learn something, student want to help from the LLM using STEAM AI agent. That's the basic applications I will create. So what would be the agentic flow for it? That's we'll talk about now. Okay, so user will come and then put some questions. It will go to a router, and the router will decide what type of task, yeah, what type of questions ask. I need to explain it, or yeah, I have to some calculate it. Okay, so might be user, yeah, student can ask many questions for uh, for building a small agent. Will take two tasks here. Okay, we'll create only two tasks. You can create n number of tasks here, but if we create add two task LM applications, so then you can add more tasks to your agent also. So one task is explanation. The explanation. Second would be a calculator. And finally, your agent would answer to the user. So that is the complete flow. Step by step, we'll build this flow. Okay. So what is the first step? What do you need to be import at all? So you need to install, pep install this LangChain library. If you install like LangChain, then you can import all this one. And there are two ways to do it. So I already explained that LangChain, yeah, LangGraph both are support. If you want to onboard any enterprises API, they can use this just in environment variable. You have to say it is OpenAI key and OpenAI endpoint. Whatever other any key and endpoint, if you want to use any OpenAI library, yeah, OpenAI LLM powered any APIs, so that's fine. Second is if you want to use your own on-premises, yeah, you want to already install Olama, you want to run a small LLM behind that can be done. So I will explain how you can run a very small with the limited CPU in 2 GB RAM, 2 GB RAM, and 2 or 4 core CPU. I can run a small LLM powered small LLM. So coin 2.0, why this one 0.15 billion parameter, and this can be run on 2 RAM of any system that have 2 RAM. So for installing Olama and everything, I created this install Olama file. So this is the install Olama file. Just call install. Just you pull it, then everything fine. Then you can just do Olama serve. Then it will run this Olama 2 0.5 billion parameter LLM. So it will run in your machine. If you are using Linux machine, so this is very basic. If you are using Windows machine, there would be some different steps, then you can follow, but very easy. You can run on Olama. So there are two ways I already explained. Okay, so I already running this basic small LM in my this machine, Ubuntu machine, and it can be run 2 RAM. So my machine only have 2 RAM. This machine I hosted to Azure, so I just take 2 RAM, 2 CPU machine on Azure and just running there only. You can run over your MacBook, yeah, your Ubuntu machine, your laptop, Ubuntu laptop, whatever, blah, blah. That's fine. So both way, if you don't want to install anything Golama or LM, then you can go for OpenAI, yeah, whatever API, Hugging Face API, what different another LM powered application. So this how we can create a LM object using this OpenAI high level APIs. So that is the first step. So this step is belong to get on board your LM to your agent. Now main things should like starting here. So first we will create a router chain. Router chain will decide which tasks I have to perform. So here what you do here in the router. So you are writing a basic template here. It will decide it ask whatever question from the user. It return is as query related to explain, yeah, calculate. If query related to explain, then it will go LLM, to LLM for explain task. If you is need to something calculate, then it will go to calculate. This line is very important for here. So here this pipe operator is there. So this line creating a chain. First input would be a prompt. Prompt will go to your LLM. LLM will reply the answer. A structure output, it will give you like string output, it will give in the particular format. So here it will deciding it's explain, yeah, calculate. Okay, so it's explain whatever output, so that same output it returns. So this chain already built. Okay, down now router know that is what is chain here, and router know which task needs to be performed. Based on this decision, agent will decide it. Okay, now I have to call which LLM again. So now will create another chain, one chain for this task. It would explain the question. Okay, explain clearly for the student this question. So this will explain, ask the question. Second is will create a calculation chain. So this chain also we create. So calculate LLM prompt. So I think we are writing here this chaining thing. It would be similar to a runnable function. In runnable function, just we are passing to argument prompt which LLM use and what structure output we needed for it. So this chain created. So here we 3 chain created. One is router chain that will decide that which task need to be performed here. Second is explanation chain that will give you output for whatever question asked to user that need to be explained. If user question is related to calculate, then it will calculate something and give you the answer. And finally is the manual routing. So this is very important. So this is manual routing logic we are returning, and state also we are returning. So here if questions, so okay, now we are creating a complete chain here step by step. So what first is in info, user questions will come, then it will go to router chain. It understand the question like, okay, this task need to be performed. Task is need to explain a calculate task. If task is calculate, then it will go invoke the calculate chain. If another, then it will go invoke the another chain. Another means like here for explain. Finally, these runnable functions are used. So runnable, we are passing this chain. So whatever chain we are passing here, it will go to this runnable. And finally, steam agent we are assuming. And end of this application, final our agent will work here. Finally, we are ready to run this agent. And steam agent.invoke. Anyway, if we calling this invoke function, then runnable function inherently will call all the invoke applications, and the chaining will complete here. First we'll go to router, we'll decide the task, then whichever task is coming, then perform that task and give the response to the user. And this is the responsibility. Why does the increase temperature? Why increasing temperature? Increasing register in the metal. And this is the answer given by the LLM. So how end to end this LLM we build, this agentic application will build with the LangChain, and same application, same agentic application, AI application will build with LangGraph also, but it would be different. In the next video, you will understand it how LangGraph and LangChain differentiate. Same STEM agent will build with the LangGraph also. Then you will understand LangGraph and LangChain comparisons. How LangGraph is more effective if your system is multi-agenting and if need to be manage your state. So that will go in next video. And this is complete flow. I just recap it. If this agentic application, okay, we want to build a STEM agent, that would flow is user will come, then router this decide which task need to be performed. Each task we created in the LM in the agentic workflow, and finally we write a complete sequence, and final answer will get by the final router. So these are complete flow of this LangChain. So we build end-to-end application with the LangChain. Thank you so much for watching this video. Thank you. And yeah, last is this repo I will show in the GitHub YouTube descriptions. You can download this one and you can run in your local laptop, local machine, whatever you are running and learning at all. Thank you so much for